In this video, we're going to have a look at how to simplify algebraic expressions with division. Example 1. Simplify. In A, we have one term with division. And just like with multiplication, because it is one term, we're going to focus on the sign, the constant, and the variables. So starting off with our sign, we have a plus divided by a plus, which is positive. Then for the constant, we have 15 divided by 3, and that gives us 5. And for the variable, I'm once again going to choose to use my exponential laws. Before we do that, I'm going to remind you about the division law. In this case, we have 5 x's in our numerator, and they should be divided by 2 x's in the denominator. So once expanded, we can simplify by saying x divided by x is 1, and again another x divided by x is 1. This means we are left with 3 x's that are multiplied in the numerator, so that is x to the power of 3. Our exponential law says that when dividing, we can simply take the exponents and subtract them from each other to also get to x to the power of 3. In B, once again, we have one term, so I'm going to immediately start off determining the sign, and here we only had a minus in front, so it stays negative. Just a reminder that the minus can be written in the numerator, or in front of the fraction like in the example, or in the denominator. All of these indicate the same thing, which is a negative term. Next, we can determine the constant by dividing 21 by 7 to get a value of 3. For my variables, I'm going to use my exponential law and start off with the base of x. And I will do that by saying 10 minus 3 gives me x to the power of 7. And then for the base y, you need to remember that the denominator has an exponent of 1. So here we will say 6 minus 1 gives me y to the power of 5. In question C, we follow the same route and start off with the sign, which in this case is positive. Next, when I move on to the constant, you will see that 2 cannot be divided by 10, but we can simplify it. I can divide both top and bottom by 2, and that will give me a fraction of 1 over 5. When I move to the variables, I will start off with the base of x, saying 4 minus 3 is x to the power of 1, which you don't have to write. And for the base y, I will take 2 minus 3, and that will give me y to the power of minus 1. This answer is acceptable, but the question can also state that you have to leave your answers with positive exponents. This means we need to make a plan with the y to the power of negative 1. For this, I'm going back to the expansion of y to the power of 2 divided by y to the power of 3. Here we can simplify by saying y divided by y is 1 and another y divided by y. So here we can see that the y that is left over is in the denominator, and that is what the negative exponent indicates. So if the question was simplify and leave your answer with positive exponents, we would have to write 1 and x in the numerator over 5 and y in the denominator. And that is why when dividing variables, I prefer to start off determining where I have more of a specific variable. So here I would still simplify to 1 over 5. But when it comes to the variables of x, I will start off saying I had more x's at the top, and that is why the x to the power of 1 will be left in the numerator. For the y values, I had more in the denominator, and that is why the y's that will be left will be in the denominator. Then I move from the bottom and say 3 minus 2 is y to the power of 1. In example 2, we're going to have a look at what happens when the numerator has more than one term. In example A, the numerator has two like terms because the variables are exactly the same, and that means we can add them up. Because remember, you can only add up like terms. So here we will have a certain amount of x to the power of 4s, and to determine how many, we add up the coefficients. So here we will have 8 x to the power of 4, and this should now be divided by 2x. Next, we need to do normal division. This will be a positive value, and then we have 8 divided by 2 is 4. For the variable, we have 4 minus 1, so that is x to the power of 3. In B, we now have unlike terms because the variables are different, and this means we cannot subtract them to form one term. So here it is now important to realize that both of those terms actually have a denominator of 2x to the power of 2. Before we continue, let's just quickly have a look at a normal fraction, like 2 over 4 plus 1 over 4. We already know that when we have the same denominator, we can make it one denominator and add up the numerators. But in our case, we are now going to use this backwards and say, because we have two values added up in the numerator, we can break it up into two terms, both with the same denominator. So in example B, I'm going to take the 10x cubed and put it on the denominator of 2x squared, and then subtract the 6x squared also on the denominator of 2x squared. Now we can simplify each fraction individually. For the first fraction, we have a positive value, and 10 divided by 2 is 5. And for the variable, we have x to the power of 3 minus 2, which is 1. For the second fraction, we now have a negative value, and then 6 divided by 2 is 3. For the variable, we have x to the power of 2 minus 2 if we use our law, which will be x to the power of 0. When we did exponents, we also said that x to the power of 0 is 1. And the reason for that is that anything divided by itself is 1. So here our final answer is 5x minus 3. In example C, we once again have two unlike terms in the numerator. So again, I'm going to start off taking each of those terms and placing it on the denominator. So taking the first term and putting it on the denominator, I'm going to add the 12x to the power of 4, y to the power of 6, also on this same denominator. For the first fraction, when I simplify, I will have a minus divided by a minus, which becomes a plus, and then 4 divided by 4 is 1. For the variables, the x, we have an exponent of 2 minus 1, which is 1, and for the y, we also have 3 minus 2, which is 1. In my second fraction, starting off with the sign, we have a plus divided by a minus, and that will give us a negative value. Then 12 divided by 4 is 3. And moving on to my variables, firstly, we have x to the power of 4 minus 1, and that is 3. And finally, y will be to the power of 6 minus 2, and that will be 4.